Hello Kriten. Let's have another video in which we speak about resistance. Alright, this time we're going to speak about resistance. In previous videos we learned about potential difference, in which we define potential difference as the work done per unit charge. Right, potential difference is equal to work done divided by charge, work per unit charge. We also learned about electric current, which is the rate at which charge flow through a circuit, okay, or through a component of the circuit. That is electric current, how fast charge flow through a circuit. Now we're going to learn about resistance. Now, the symbol for resistance is R. Now, the symbol for resistance is a capital R. And resistance is the opposition to the flow of electric charge. How difficult charge flow through a circuit or through a component of a circuit. That is what we call resistance. Now, let's say we have a resistor. We have part of a circuit, we have a resistor of a specific material. That resistor, like everything else around you, is made out of particles, many particles. Right? Now, the charge, the electric charge, electrons have to flow past through those particles. Now, how difficult those electric charge struggle, how much they struggle to pass through the conductor because of those particles, that is what we call the electric resistance. The more difficult it is to pass through the conductor, the greater the resistance. The easier it is, the smaller the resistance. So, how difficult it passes through a conductor, that is what we call resistance. Alright, so now this is electric charge that is passing through a conductor. Alright, now electric resistance or just resistance of a resistor R will be equal to the voltage or potential difference divided by electric current. This is a law where we will explain a little bit later in further grades. For now, resistance is going to be equal to potential difference divided by current. And potential difference, resistance, which the symbol is R, is expressed in ohm. The unit for resistance is the ohm. The symbol is omega, which is a Greek letter. Right. Now, there are many factors that affect the resistance of a resistor. Alright, remember there are substance materials that don't have much resistance, but most of them have resistance, and there are factors that affect the resistance of a resistor. So we are going to name the factors and explain a little bit each of them. So let's go to factors that affect the resistance of a resistor. And just before we go to the factors, let's record what is the symbol for resistor in the electric circuit. The symbol for resistor we are going to be using is a right angle with two lines at the end. That is the symbol for a resistor. However, in some books you will be looking something like this. This could also be a resistor. Alright, this is resistor with resistance. Now, what factors affect the resistance of the resistor? The first factor will be the type of material. So different materials, we have different resistance, and that have to do with the amount of particles, the distribution of the particle within that substance or that specific material. The second factor will be the length. The length of the resistor. The length of the resistor. How long the resistor will be. Okay, length of the resistor. For example, a resistor of the same material that is longer in length will have a greater resistance than a resistor that is shorter in length of the same material. If we call this resistor, for instance, resistor R1, and this is going to be R2, and they have the same, or they are made of the same material, then we have that R1 is greater than R2 because the resistor is longer. Okay, those are the first two factors. Factor number 3 will be the thickness of the resistor. Factor number 3 will be the thickness. Thickness of the resistor. If the resistors are made out of the same material, a resistor that is thicker will have less resistance than a resistor which is less thick, made of the same material. If these two resistors are of the same material, then we have that this is R1, this is R2, then the R1 is smaller than R2 because it's thicker. Alright, and the last factor is the temperature. The last factor that affects the resistance is the temperature. Now, remember from the kinetic molecular theory, when you increase the temperature, the particles here inside the resistor will move further. They will start moving more, and therefore they will start blocking the path of the electric charge. So, if the temperature is big, then the resistance is big. If the temperature is small, the resistance is smaller. This is all for now. Next time we'll speak about the resistors that are connected in series. Thank you.